Hey everyone, and welcome. Ever thought you could be a detective, but in a science lab? Well, today's your day. We're going to uncover the secret signals of chemistry, figuring out how to spot a chemical reaction with nothing but our own eyes and maybe our sense of touch. So let's get our detective hats on and dive right in.
So here's the big question, right? How do you really know when stuff is just mixing together versus when it's actually transforming into something totally new? Turns out the clues are usually hiding in plain sight. Our mission today is to learn how to spot them and solve the mystery. Okay, let's open up our first case file. This one comes from a little experiment called Activity 1.2. Our investigation starts with a really simple question. What happens when you mix two liquids that are both perfectly clear? Like water. Well, the answer is a lot more exciting than you might think.
I want you to imagine you're in the lab with me, okay? So, in your hand, you're holding a test tube with some clear lead nitrate solution. Now, you grab another bottle with a different clear liquid, potassium iodide, and you just pour a little bit in. Simple enough, right? But this is where the magic happens. Okay, this is it, the moment of truth. We've mixed two see-through liquids. What do you think is going to happen? You think it'll just stay clear? Maybe it'll get a little cloudy? Let's find out. And boom, just like that, out of absolutely nowhere, this vibrant, solid yellow thing just appears. We went from two clear liquids to a bright yellow solid in a split second. Now, that isn't just mixing. That's a brand new substance being created. And that sudden, dramatic color change, that is our first huge clue that a chemical reaction has definitely happened.
All right, detective, on to our next case. This one's from Activity 1.3. Now, we're not looking for a color change this time. We are on the hunt for totally different kinds of clues. So, picture a flask, one of those triangle-shaped ones. We're going to drop a few little gray pieces of zinc metal inside. Nothing much happening yet. But now, we're going to carefully pour in some dilute acid. So we've got a solid and a liquid, and they're about to meet. Lean in, get a really close look at the surface of those little zinc pieces. What's going on? Is anything happening at all? Or is there something more? And there it is, bubbles, a whole fizz of them just erupting off the zinc. And let me be clear, this isn't boiling. Those bubbles are actually a new gas being created right there in the flask. The formation of a gas, that's our second big clue. But wait, we're not done investigating. Now let's switch gears. We've used our eyes, but what about our other senses? What if you were to carefully put your hand on the outside of that glass flask? Sometimes the biggest clues aren't the ones you can see. Oh, it's actually warm. The flask is getting noticeably warmer. That means energy is being released in the form of heat. And that gives us our third absolutely crucial piece of evidence. We didn't just see this reaction, we felt it. Okay, so we've gathered all our evidence. From case 1, we got a crazy color change. From case 2, we saw fizzing gas and we felt heat. It is time to put all these clues together and crack this case wide open. Let's just do a quick recap. Case 1, two liquids made a colorful solid. Case 2, a solid and a liquid made gas and heat. See? We started with totally different things, but both times we got these dramatic, obvious changes. These are the signals that a chemical reaction took place. And that brings us to the solution of our whole mystery. Here's the big takeaway. When you see a change in color, or when you see a gas being formed, or you feel a change in temperature, you can be pretty darn sure you're watching a chemical reaction happen. These are the telltale signs, the smoking guns of chemistry, if you will. So think about it. The next time you see a piece of metal rusting, or drop a bath bomb in the tub and see it fizz, or even just watch your toast turn brown, you'll know what's really going on. So the real question is, now that you're a chemical detective, what other reactions are you going to spot out there in the wild? The world is your laboratory now. Go have a look.